Welcome students. Let's continue the previous presentation. Let's move on to see the topic on purpose of database system. Let's see the drawbacks of using file system to store the data. Data redundancy and data inconsistency is the first drawback. Second one is difficulty in accessing the data, data isolation, integrity problem, atomicity problems, concurrent access anomalies, and security problems. Okay. Let's see the disadvantages of using the file processing system or file system. The first drawback is data redundancy. So it's nothing but the same information duplicated in different files. So data duplication is nothing but data redundancy. Data redundancy leads to the problem of memory wastage. Okay, but let's see one example for data redundancy. Let's consider some customers have both kinds of accounts. The first account is saving account and the current account. In this case, the data about the customers, that is name of the customer, address, email, contact number will be duplicated in both the files. And file for saving accounts also and file for current accounts. This leads to requirement of higher storage space. In other words, the same information is stored in different locations or different files. So it leads to the memory wastage problem. Okay. Let's see the next problem is data inconsistency. Due to data redundancy, it is possible that data may not be in an inconsistent state. May not be in consistent state. For example, consider an address of some customer is changed and that customer has both kinds of accounts. Now it is possible that this changed address is updated in only one file and leaving the address in other file as it is. So as a result of this, the same customer will have two different addresses in two different files, making sense that data is inconsistent at two different places. The next problem is difficulty in accessing the data. So accessing the data is not convenient and efficient in file processing system. The conventional file processing environments do not allow needed data to be retrieved in a convenient and efficient manner. More responsive data retrieval systems are required for general use. So difficulty in accessing the data. Let's see one example. Suppose that one of the bank officer needs to find out the names of all customers who lives within a particular postal code area. The officer asks the data processing department to generate such a list because the design of the original system did not anticipate this request. There is no application program on hand to meet this requirement. So there is, however, an application program to generate the list of all customers. The bank officer has now two choices. Either obtain the list of all customers and extract the needed information manually, or ask the system programmer to write the necessary application program. Both alternatives are obviously unsatisfactory. Suppose that such program is written and that several days later, the same officer needs to trim that list to include only those customers who have an account balance of rupees or $10,000 or more. As expected, a program to generate such a list does not exist. Again, the officer has the preceding two options, neither of which is satisfactory. So, as time goes by, the officer is requesting new requirements. So thus the problem arises to write a new application program based on the requirement. It's a tedious one in case of using the file processing system. The next problem is limited data sharing or data isolation. The data are scattered in various files. Different files may have different formats, and these files may be stored in different folders or directories, maybe of different computers of different departments. So, due to this data isolation, it is difficult to share the data among different applications. The next problem is integrity problem. Data integrity means the data contained in the database is both correct and consistent. So integrity means correctness of the data and consistency of the data. For this purpose, the data stored in database must satisfy certain types of constraints. Constraint means rules. It has to satisfy some rules. For example, a balance for any account must not be less than 0. So any bank will be having such constraints. Such constraints are enforced in the system by adding appropriate code in application program files. When new constraints are added, such as balance should not be less than rupees 5,000, the application program needs to be changed. But it is not an easy task to change the programs whenever required. Okay, atomicity problem. Any operation on database must be atomic. This means an operation either completes 100% successfully or 0%. That is, it does not happen at all. For example, a fund transfer from one account to another must happen in its entirety. But computer systems are vulnerable to failure, such as system crash, virus attack. If a system failure occurs during the execution of fund transfer operation, it may be possible that amount to be transferred, say 500, is debited from one account but is not credited to the another account. This leaves database in an inconsistent state, but it is difficult to ensure atomicity in a file process. This is the problem of atomicity. So atomicity means either the operation must complete in its entirety or does not happen. Next problem is concurrent access anomaly. Multiple users are allowed to access the data simultaneously or concurrently. This is for the sake of better performance and faster response. Consider an operation to debit. That is, suppose if you are going to withdraw an account, the program reads the old balance and calculates the new balance and writes the new balance back to the database. Suppose an account has a balance of rupees 5,000. Now, a concurrent withdrawal of 1,000 rupees and 2,000 rupees may leave the balance of rupees 4,000 or rupees 3,000 depending upon the completion time rather than the correct value of rupees 2,000. So this problem occurs while using the file system. Here, concurrent data access should be allowed under some supervision. But due to lack of coordination among different application programs, this is not possible in file processing system. Okay, the next problem is security. So database should be accessible to the user in a limited way, in a secured way or restricted way. Each user should be allowed to access data concerning his application only. For example, a customer can check the balance only for his or her own account. He or she should not have access for information about the other accounts. That is, other account details is prevented for their own. But in file processing system, application programs are added in an ad hoc manner by different programmers. So it is difficult to enforce such a kind of security constraints. Okay. So this is a pictorial representation of traditional method of data storage. So you'll be having the loan processing application program, and for the fixed deposit processing, for that purpose application program will be there, and for transaction application program will be there. So all the three application programs will act on the file system, and different files are maintained. Okay? Customer detail, customer loan detail, customer fixed deposit detail, customer transaction. So this was the traditional method of data stored in a file system. So in the traditional approach, the information is stored in flat files which are maintained by the system of operating system. So the application programs goes through the file system, to access the data from the flat files. Okay. So where does the DBMS fit in? So the DBMS fits on the top of the file. Now the DBMS acts as a layer of abstraction on the top of the file system. You might have observed that for interacting with the file system, we are using a high-level language functions, for example, C file handling functions and for interacting with the DBMS, we would be using the query language called structured query language, that is SQL. Okay, so let's see the difference between the file operations and the database management system operations. So this is a file system interface and this is the DBMS interface. Suppose if the end user wants to access the files that is stored in the disk, they have to, for each and every data needs to access, they have to go for writing the application programs. And with the help of the higher level language as an interface, that is for example C language, they can access the data, that is files from the disk storage through the operating system. So this was the interface carried out in the file system. Okay, coming on to the DBMS interface, the end user will be accessing the databases through the structured query language. So this is SQL will be acting as the interface. Okay, and that's the difference between. So file system, they will be using the high level language called the C language, and regarding the DBMS, we will be using the query language called structured query language. And these are the references used for preparing the slide.